Now I think it's time to continue the extended application of these annuities and perpetuities. So we start by defining our capitalized cost. Now this capitalized cost is the property sum of the first cost and the present worth of all costs of replacement, operation, maintenance, and this maintenance could take a long time or it could last forever. So there are at least three cases of this capitalized cost, and we'll be dealing with just the three cases. Now, for the first case, we have no replacement, only maintenance, and or operation every period. So in short, walang papalitan dun sa ating mga existing equipment. Of course, kailangan lang natin siyang i-maintain. So this is given by the sum of the first cost. So your capitalized cost would be your first cost or the fixed cost, and then you add your present worth perpetuity divided by the interest rate. So that's just the annuity divided by the interest rate, which gives us your perpetuity. This is the easiest one without any replacement, just the maintenance that takes forever to finish. Actually, it's not actually to finish, but it's a long-running maintenance, so you have to always do this maintenance for every month, every year, or whatever is the maintenance schedule of the company. Now for number two, if there is this replacement and no maintenance and or operation, so you have to add the first cost, and then you have this formula which gives you the present worth of perpetual replacement. So this is usually given in terms of x. So if you have x, then this is this equivalent equation. So given this uniform series future worth factor, you just have to divide that to 1. So basically, yung reciprocal na sinking fund factor, and then you multiply that with the perpetuity of this expression, and then you should be able to get that amount that you would be using for the replacement. So in short, ito yung mga examples nung halimbawa, may certain equipment ka and then we have to remove, for example, yung mga pyesa niyan kasi hindi na siya kayang i-maintenance. Actually, hindi natin talaga siya mini-maintenance kasi after gamit mo, dispose na natin, then palit. So, yun yung cases like this, no? Yun yung second case wherein there's no maintenance of that certain part but replacement. Siyempre, yung maintenance na tinutukoy natin dito, ito yung per equipment lang, no? Hindi siya yung parang overall maintenance. Kasi, siyempre, iba't ibang, iba't ibang computations yun per, let's say, machine or equipment. Now, ito yung description ng bawat letters dito na mas detailed. Yung S natin is amount needed to replace the property every K period. So, in short, ito yung cost niya, no? And then yung X is, this is the amount with corresponding sinking fund factor na nakikita nyo dito, no? And now x sub I or xi is the interest on x every period, the periodic deposit towards the accumulation of s. So in short, this is the formula of finding your x based on the value of your s. So kung mapapansin nyo tong expression na to, diba? Kung i-incorporate mo yung uniform series future worth factor nitong ating annuity dito, meron siyang over I, and then yung over I makakancel out siya, so matitira na lang sa kanya is yung numerator nung factor na yun. So with this, we'll be left out with the same expression like this one. Okay? So ito naman yung P, amount invested on I% per period, whose interest at the end of every period forever is A, while X is amount invested now at I%, whose interest at the end of every K period forever is S. So later on, I'll give you an example just to make you understand how this K and S work. Now the third one, kasi kanina, tig-isa silang may hindi nagme-maintenance pero may replacement. So ngayon naman is parehas meron, may replacement and then meron ding maintenance. So you just have to add yung fixed cost mo, syempre yung first cost, and then yung perpetual maintenance na ginagawa natin, which is usually equivalent to A over I, and then of course yung replacement cost na ginagawa natin din every period, so that is X. Syempre yung X naman, depende rin yun sa S mo. Okay, so ito yung equation, S divided by 1 plus I raised to K minus 1, which is actually the uniform series, again, uniform series future worth factor times the interest rate. Okay, now how about amortization? So itong amortization naman is any method of repaying a debt. So we do this by doing some equal payments at the interval of let's say you set the interval. So yun basically yung ating i-amortize na payment based dun sa mapag-usapan natin o mapag-agrihan nung pinag-utangan mo, no? Now basically this is the same as annuity. It's just that we add, mabasa dito, no? meron siyang additional condition na sineset, which is the compounding or deferred factor natin. So, for example, we compound the interest or yung annuity natin, dinedefer natin. So, yun yung mga condition na sineset. Kasi, for example, nag-agree kayo na umutang ako sa'yo, okay, umutang ako sa'yo, pero hindi ko pa ba kaya magbayad sa for the next 3 months. So, ang gagawin nung pinag-utangan mo, sige, magbayad ka na lang starting sa 4 months, I mean 4th month, pero we have to amortize your payment in the equal payments mula supposedly bayad mo siya dun sa first month up until the end duration of your payment. So, pwedeng maging ganun yung agreement nyo, and then with that agreement, you create amortization schedules so that you can see kung ano ba yung nangyayari sa binabayad mo. And basically, it's just this annuity na medyo nagkaroon tayo ng modification. Yun lang talaga yung amortization. So, pag naman inflation, alam naman natin yung inflation is yung pagtaas sa mga presyo ng ating mga bilihin, no? Pag narinig natin may inflation rate na ganito, so expect natin na tataas yung presyo natin bilihin. And then yung purchasing power ng ating pera will be decreasing. So, yun yung effect ng inflation. Now, the inflation can be related in terms of the future cost and the current cost of the commodity. So, ito yung future cost niya, and then ito yung purchasing cost or yung current cost nun. So, i-multiply natin sa 1 plus F, which in this case, yung F is the annual inflation rate, and then we raise that to the number of years na mag-exist yung ating inflation, or we could just say na ito yung duration kung saan mamimit natin yung future cost ng ating present current cost ng commodity. So, ito yon, may equation 27 siya, and this is used when the investments made during which inflation is taken into account. So, we should always remember na effective lang yung inflation rate natin dun sa time na nagkaroon ng inflation. So, for example, hindi naman nagkaroon ng inflation sa 2007 or 2008, and then your computation is on 2009. So, you're not allowed to use that certain inflation rate because hindi siya nagmamatch dun sa certain time na yon. Kasi, di ba, this is time relevant. So, you have to use the correct inflation rate or the correct inflation rate. Now, as you can see from this expression, yung ating F is equal to P times 1 plus I all over 1 plus F. So, we can represent this in terms of future and present worth. Now, pag ganito yung case natin, mapapansin natin na this can be expressed in terms of the interest rate, and then you just have to divide your present worth in terms of 1 plus F. That is the annual inflation rate plus 1, and then you raise that to the number of years na you're concerned with. So basically, yung effect ng inflation rate, alam natin na this will be greater than 1. And knowing na greater than 1 to, so mababawasan yung ating future worth instead of just having this 1 plus I raised to n, which is basically the simple interest rate na ginagamit natin to find the future worth. Now, I think this is the last, hindi pala. So, last two of our time-related monetary values would be the uniform arithmetic gradient and then the geometric gradient series. Now, for the first one, the uniform arithmetic gradient, so we could say that you just look at the cash flow diagram para mas madali, no? So, ito yung description niya. So, if we start with 0 and end up with n period, no? And then, syempre, yung I natin is still the same, effective interest rate per period yan. And then, kung mapapansin nyo, sa second payment niya, nag-start tayo sa G, okay? So, ito naman is, nag-start siya sa payment na G. So, imagine, we have 400, okay? And then, yung third payment niya, naging 2G na. So, na doble, let's say, ang sabi ko 400, din naging 800 na. And then, sa fourth na, naging 3G. So, ito ay hindi signal ha. So, sa 2G, 2G, 3G, and then, so kung mapapansin nyo, so nagkaroon tayo ng time skip dito. And then, dito sa n-2, we have n-3G, n-2G, and then n-1G. So, basically, nag-a-add lang tayo ng nag-a-add nung ating previously paid na previous payment na ginawa natin. So, diba dito sa una is G lang. So, syempre, sa pangalawa, 2G. So, kung magbabayad ka lang ng certain value na G, so, ito lang yun, yung G mo na lahat, diba? So, you have to add yung previous payment na ginawa mo. In this case, kaya, diba, we did 2 payments previously. So, you add that. And then, for this one, accumulated lang yan. So, parang ano lang yan, alam niyo ba yung arithmetic series sa math. So, yun lang din yun. 1, let's say 1 plus 2 plus 3 plus 5. So, ganun lang naman yung mangyayari dyan. Okay. So, ito, just to read this, the previous figure is a cash flow diagram of a sequence of end of period cash flow increasing by a constant amount of G. So, yung sinasabi ko kanina na nadadagdagan lang siya in terms of G. And then, G is known as the uniform gradient amount. So, kapag magko-compute tayo ng values and then we need to find G, we call that the uniform gradient amount. And then, therefore, the present value equivalent is the sum of the annual payment or uniform series based on the initial payment and the uniform gradient amount. Okay? So, in short, kung ganun pala yun, so we have the present worth of the annuity and then using this gradient. So, we have to multiply our annuity with the present worth uniform series factor and then this G using the gradient factor. And this is what is meant by this expression. Ito medyo familiar tayo dito kasi this one is annuity pero this one is for the gradient. So you just have to remember this formula and I think masasolve na natin yung mga ating mga uniform gradient arithmetic series. So ito lang yun. Okay? So, kung mapapansin nyo, medyo kamukha siya nung future worth. It's just that meron siyang minus n dito. Pero basically, ito yung formula nun. And then, meron kang simple interest rate dito na parang sinking fund factor, ganun. Not sinking fund factor, but yung reciprocal ng simple interest rate. Okay? So, yon. And then, kapag naman future ating pinag-uusapan, pwede rin nating i-relate itong formula na to using this one. Dapat this one is F. Okay, so make sure you change this one in your handout. So this is F, not P. Okay? So, yan, tandaan nyo na lang yan. That's F. And basically, kung mapansin nyo, yung ginagamit natin dito is yung same lang din na factor for your A. So, I mean, ibang factor for A and then almost the same lang tayo for G. Okay? So, kung mapansin nyo, almost same lang tayo ng value dito sa G, pero for this one, we use the future worth factor uniform series natin. And then for this one, tatanggalin lang natin itong 1 over 1 plus I raised to n. Kasi we're basically talking about the future, diba? Diba this one is for the present that you have to take this to the future. So, basically, if we're talking about the future, hindi mo na kailangan incorporate itong gantong expression with the gradient part. Kaya nawala siya dito, no? Pero make sure na this is F. Now, how about the geometric gradient series? So, kung meron tayong add, meron din tayong geometric gradient which gives us yung parang multiplication part. So, with this, if we started with 1, so A sub 1 yun, then 2, 3, and until this, the end of the period. So, may time skip din dito. And then, kung mapapansin nyo, yung ating A sub 2 is equal to A sub 1 and then 1 plus F bar. Yung ating A3 would be A sub 1 and then 1 plus F bar squared. So, basically, itong 1 plus F bar natin, nasan ba yun? Andito yun eh. In-explain dito yan. Yung 1 plus F bar natin is, yan. This is the average rate, yung F bar natin. Kasi, kung halimbawa, nag-change siya on a certain average percentage, then we can relate that in terms of a percentage then, like the interest rate. So, magkaiba pa sila, no? And then, you just have to use this formula to be able to determine your uniform geometric gradient series. Now, anong pinagkaiba nito? It is something like a piecewise function, no? Kung uunahin natin ito, we have to make sure na yung ating I minus F bar is not equal to 0. So, therefore, there is a difference between this interest rate and then the average rate of change. Pero kung wala naman, if I is equal to F, then we cannot use this because this will be 0. So, maging undefined yung ating equation, we'll be using this expression. And kapag ganito na yung nangyari, mas madali sa atin kasi yung ating interest rate would be equal to the average rate of change. And this gives us yung parang formula natin to find our present worth using the the compound interest rate percentage that we use. And then A1N lang would be your first amount, and then you just have to multiply that with the number of periods that you will be paying that certain amount. Okay? So, yun lang ang atin for the geometric gradient series. So, basically, ito na yung kabuuan ng ating money time value. So, I hope na may nagets kayo dito sa lesson na to, and I think to end this discussions, let's solve the rest of the problems that actually involve this kind of problems or kind of equations. Now, let's start with number 11 kasi ito yung in-skip natin before since di pa natin na-discuss yung about inflation. But then again, this inflation will just result to a decrease in the expected future worth of a certain present worth. So, let's have this, no? A man deposited or deposits 50,000 in a bank account at 6% compounded monthly for 5 years. If the inflation rate is or of 6.5% per year continues for this period, kasi we have to make sure na yung ating period na solvent would have this kind of inflation. Will this effectively protect the purchasing power of the original principal? Now, to be able to determine if this will effectively protect the purchasing power of the money that you've deposited, we have to make sure na yung ating future worth would be greater than our present worth kasi yun naman talaga yung goal ng ating mga pagde-deposit, di ba? So, if we have the present worth that is equal to 50,000, okay, and then yung ating pera is we have a bank account 6% compounded monthly, so yung ating nominal rate of interest is 6%, and then we have compounded monthly, so that is 12, and then the duration would be 5 years. Okay, so basically we have this given, and then yung inflation rate natin is 6.5%. Now, as you can see, yung ating nominal rate of interest mas mababa kaysa sa ating inflation rate. But let's check what will happen. Again, yung ating future worth is given by P times 1 plus I raised to N and then 1 plus F raised to N. Okay, this is the formula for your present future worth given na meron tayong inflation. So, if that is the case, then we have the present worth, this is 50,000. Okay, and then 1 plus, ano ba yung ating I? So, the interest rate would be the nominal 6 or 0.06 divided by 12 and then raised to 12 times the number of years, which is 5 years. Okay, and then we divide this by the annual inflation rate, so that's 1 plus, this is annual, so it's 0.065. Okay, and then how about the exponent? So since diba inflation rate ito per year and we have 5 years, so that is 5. So wala na siyang 12 kasi that is used for the discrete payment that we have. Okay, so basically if you try to compute for this, the answer would be equal to, so the answer is equal to 49,224.9939. Okay, so this is your answer, and the question is, will this effectively protect the purchasing power? So the answer is no. Okay, so yes or no lang naman yung tanong, so no yung sagot natin. Pero syempre kailangan natin improve yung mga ganong tanong, no? Kasi dapat yung F natin is greater than our P. Pero dahil nga meron tayong inflation, we have to expect na mas ano yan, na mas bababa. Though sometimes meron man tayong inflation rate pero hindi naman siya bumababa talaga. Now, one good indicator is that if you try to compute for the effective rate, okay, so itong buong to, syempre kasama na yung may minus 1 doon, no? So if you try to compute for this effective rate at saka ito, and syempre, kailangan mas mataas yung numerator mo kasi denominator. Kasi kung hindi kung mas mababa yung numerator mo, then you have to expect na hindi magiging profitable yung iyong savings for that. So, just remember na yung pag mataas yung inflation rate and then yung interest rate mo is just given by that certain amount, and then you're expected to have this money affected by the inflation rate, then just remember kung ano yung mangyayari. Pero syempre yung mga companies naman or bank, hindi naman mag-o-offer nung mga gantong case na magkakaroon ng effect sa inflation. So basically hindi talaga siya ganun, no. Pero syempre for case to case basis, when you're offered and then meron siyang certain amount ng inflation na kino-consider, then you have to make sure na you try to compute first before you give a go signal to that certain offer. Okay, so let's move forward na sa next item.